Chapter 8, Engine Feedback Assemblies. In this chapter, you'll be able to identify the feedback components, the role of the engine timing gear train in managing engine functions, procedures to time an engine gear train, role of the camshaft in a typical diesel engine, interpret terminology used to describe cam geometry, inspect a camshaft for wear and damage, procedures to remove and replace camshaft bearings, identify valve train components and run an engine, list the type of tappets cam followers used in diesels, and inspect pushrod tubes and pushrods and evaluate their serviceability. We have the role of the rocker assembly, role of the cylinder head valves, and interpreting the terminology used, and outline a procedure to recondition a set of cylinder head valves, identify valve margin and other critical wear machining tolerances. How do valve rotators operate? That's important. The role of valve seats and inserts outlined in service procedures. Perform lash adjustment on diesel engine using OEM specifications. That includes engine brakes when they're in the overheads. Perform basic failure analysis on diesel engine cylinder valves. Outline consequences of too much or too little valve lash, and that's how they affect the timing. So too little or too much valve lash will affect the timing of the valves, and that's important. And you need to create a valve polar diagram. The feedback assembly management apparatus includes the timing and accessory drive gears and camshaft tappets, valve and unit injector trains, rockers, and fuel pumping mechanisms. A diesel engine timing gears are located either on the front or the rear of most commercial truck engines. Timing gear trains are commonly located in the front, but many post-2000 engines have adopted rear-mounted gear sets. The timing gears make sure the camshaft and the crankshaft are synchronized so valve openings can be in the appropriate positions. In the case of hydromechanical engines or engines with camshaft actuated injectors, fuel injection takes place at the appropriate time. We have front gear train shown here and rear gear train. Front gear train are typically our Cummins. Rear gear train, the ones we're looking at in the shop now, are the PACCAR engines, the MX-11 and MX-13. Timing an engine gear train. Number one piston is going to be a top dead center on compression stroke. The gears are required to be timed to each other or indexed by stamp marks on the teeth that must be intermeshed. There's OEM instructions and directions for aligning timing marks and use tooling necessary to assist in timing the engine. Failure to do this correctly will not only give you a no-start condition, but can be extremely poor engine component and very serious engine damage can occur. The camshafts in most model commercial diesel engines are gear driven by the crankshaft through 1 revolution per complete cycle of the engine. So the engine crankshaft is going to turn 2 complete turns, while the camshaft is only going to turn once. So you're going to have 720 on the crank, and the cam's going to have 360. Okay, this is a linear representation of the timing of the crankshaft, what the piston's doing, what the valves are doing, and what the injectors are doing in each portion of this cycle. On our camshaft geometry, we're going to have the small base circle and center line, and we're going to have the outer base circle and the inner base circle. The large dimension is known as the outer base circle. The outer base circle minus the inner base circle is going to give you cam lift. So we're going to have the measurements of the inner base circle, measurements of the outer base circle, and that difference when subtracted will give you how much lift occurs and how much actual valve opening action is given to the cam follower, the push rod, the rocker, and ultimately the valve. The first item here is a thorough visual inspection of the lobes. Look for scoring, wear, bluing, which is heat effect of the journals. You take a micrometer to the profile of the heel to toe dimension and check the OEM specs. You check the cam lobe surface for wear using a straight edge and a thickness or feeler gauge, size to the maximum wear specification. And the ultimate way to do this, the best way, is to put the camshaft in V blocks, typically on 2 journals, and you roll it using a dial indicator and see what your run out and differential is from lobe to lobe, and that'll give you a good idea what condition the cam is in terms of wear factor. Okay, cam bushings are typically replaced during an engine overhaul, but if they're reused, they got to be measured with a dial bore gauge while they're in the block. Interference fit, cylinder block located cam bushings are removed in sequence, typically starting in the front and working our way to the back. Using the correct size driver or mandrel and slide hammer can be used. We have some special tools to take the one-piece cam bearings out of the block. So those are the type that we're going to be utilizing on our engines as we move forward with the replacement of the cam bearings. Okay, as the camshaft rotates, it actually moves linearly. The valve and injector trains transmit efforts of the cam geometry into cylinder valves and injector assemblies. The cam profiles actuates the train. The linear movement of the train is converted to rotary motion, and once again it's a rocker, and the rocker that opens and closes the valves and provides fuel injection pumping force in many engines, and in addition it'll actuate the engine brakes. Type of cam followers: tappers, solid lifters, and roller type cam followers. Roller type cam followers are used in a lot of heavy duty engines, and they have lubrication on the roller, and the roller changes position and gives the cam the best possible life expectancy because it's always on a different lubricated surface. Here's an example of a roller cam actuated valve train. Here we have the camshaft, the cam follower with a roller on it, and it transmits the rotary motion of the cam to linear actuation up to the rocker through the push rod, comes across the rocker to the valve bridge, and then to both valves. Inspecting push tubes. If an engine has push tubes, they have to be inspected for any surface deterioration, disintegration, discoloring for heat effect. The ball socket dropping on a concrete floor from 2 inches is a ring versus a dull sound. And the straightness, and this is common, testers roll the push rod on a known flat surface and see if there's any wobble in the response. If there's a wobble and you're replacing one, you're probably going to want to replace all the push rod tubes as a set. Doesn't make economic sense to straighten a push rod tube or a push rod. Typically, a temporary repair is not going to fit into the longevity expectations of today's heavy truck customers. Okay, rocker arms. Rockers are levers. They have a rocker ratio. They're used both in block and overhead camshaft configurations. This is an example of rockers here in the overhead cam situation. Okay, engines using overhead cams and fall valve design typically use one cam actuated rocker for exhaust, another for intake, and each rocker mechanically acts on a valve bridge to simultaneously open the pair of valves. Cylinder heads and valve seats. Cylinder heads provide the means of transmitting air and discharging exhaust out of the engine cylinders. Location of valves, lifts, and valve timing can influence cylinder gas dynamics. Commercial diesel engines use valve seat inserts rather than integral seats machined into the cylinder head. Primary advantage of the valve seats is that they can be manufactured from tough, temper-resistant material and easily replaced when the cylinder head is being overhauled. Okay, here, typical valve. We have a hardened tip here. We have two undercut keeper grooves. We have a valve stem. We have an inertial or fillet weld here. We have seat hardened surfaces, a valve margin on the edge, and the head of the valve. The valve margin is a critical dimension because you can only grind a valve typically once before you lose the specified margin, and it won't have enough material there to withstand the mechanical forces of the valve spring and the heat effect of combustion. Cylinder head valves, intake, exhaust. There's valve breathing efficiency, valve operation, valve rotators, and valve harmonics. Your typical intake and exhaust valve, you're going to see a protrusion and a recession differential in many cylinder heads. You're going to see that all valves and seats need to be inspected for damage. Obviously, a full overhaul would be required if you see damage in more than one valve. The seats must be ground to the appropriate OEM specifications. In the 30 and 45 degree is typical in heavy-duty engines. Material should be removed efficiently not to overheat the valves or seats, and adequate sealing valve margin must be left to ensure the valve will not melt under high cylinder temperatures. This specification is called out. The valve margin is called out by the OEM manufacturer and is in your instructions that you're downloading off of the Mitchell. Valve rotators essentially rotate the valve so the valve is never in the same position, and it helps prevent carbonization and burning or localized hot spots. So valve rotators are common in commercial cylinder heads. Valve lash settings, when adjusted, the clearance between the end of the rocker arm and the top of the valve stem and bridge. The lashes required as the moving parts heat up, they expand. If clearances were not factored in the valve train, the valves would be constantly open at the time an engine reached operating temperature, and that would not be practical. Shortcutting engine OEM recommended valve and injector settings and also engine brake will result in engine damage. Technicians know very well. Cam profiles are not always symmetrical. Some engines may have a camshaft profile with certain ramps between base circle and outer base circle for the purpose of actuating engine brakes, and similarly, valve rocker shows appearance to have excessive lash when not in its setting position is not necessarily defective. Firing order 153624 is common for a straight 6. We understand that companion cylinders 1 and 6, 5 and 2, and 3 and 4 are going to be, as a pair, they're going to be in the same position. So when 1 is at top dead center, so is 6. If 1 is on the top of the compression stroke, beginning the power stroke, then number 6 is at the top of the exhaust stroke and is experiencing valve overlap. Always check OEM service literature before checking and setting valves. Engines require valves mechanically adjusted and mechanically adjusted injectors to be set simultaneously. Failure to position the engine in precise settings can and will result in engine damage. Here's a example of a valve bridge and a yoke. They're calling the valve yoke here, and we have the bridge and the adjusting screw, and the keeper nut is on top here. The yoke guide pin is located on the top to keep the some of these are utilized in a variety of engines depending upon the manufacturer. Adjusting a valve yoke or bridge, there's a 60-degree offset here, adjusting it so that you have the correct amount of play in the bridge. Loosening or tightening valve yoke adjusting screw, the guide on the cylinder head is vulnerable to bending. Most OEMs recommend that the yoke be removed from the guide and placed in a vise to back off and final torque the adjusting screw lock nut. Adjusting valve intake. Here we are showing using the combination wrench and the hex and the feeler gauge. We like to keep the feeler gauge moving so we can see that point where we're getting the full contact and the feeler gauge is not is stationary, it's not moving. So you want to back that off just a tiny bit to get to that sweet spot. That's going to take practice to learn, but once you learn it, you understand how important the movement of the feeler gauge is to the correct lash adjustment. Tech tip, never attempt to adjust valve while simultaneously checking it with the feeler gauge. Allow the blade to be clamped by the rocker, then release it. Make the adjustment at the rocker screw, then check the gauge blade drag. It should be reduced the time spent performing a simple engine maintenance adjustment. Do not be persuaded that cylinder head valves should be set tighter than specified. This may have been acceptable at different times, but today you have to adjust them exactly to where the OEMs are specifying. Tech tip, some diesel engine OEMs recommend the use of go and no-go gauges to set valve lasts. This is because the type of gauge reduces variable elements of feel in the setting procedure. Some techs find them easier to use. Barring the engine over, you need the correct tool. The part number is part of your assignments, and you have to be able to turn the engine to the correct position, the A, B, or C position, and make sure that you have those positions marked on a flywheel or a damper so that you are, in fact, adjusting the valves in the correct sequence. Variable valve timing simply means to use vary either in opening and closing the valves, typically on acceleration. They use engine management system with flexible valve timing as opposed to mechanically fixed timing where actuated geometry is utilized. Advance or retarding the opening of intake valve, reduce fuel consumption, improve response to the accelerator, optimize cylinder compression in sync with engine load, and improve emissions by heating the exhaust gas during low load operation. Advancing or retarding opening of exhaust valves can enable faster warm-up of the aftertreatment, minimize turbo lag, and assist your diesel particulate filter regen cycles by increasing exhaust temperatures. Exhaust temperatures at the diesel oxidizing catalyst in the sweet spot is around 500 degrees, and having the ability to have variable valve timing on the exhaust will help aftertreatment achieve operating temperature. Okay, here's a valve polar diagram, especially useful so that students can learn what is occurring in each position of the cam, what the valve is doing, what the injector is doing, and have an idea of where the valve should be in the rotation of the diagram. Engine feedback components incorporate engine timing, gear train, camshaft valve, unit injector trains, and in some cases, injector pump apparatus. They also include the engine brake. The actuation mechanisms for fuel injection components are examined in sections dealing with specific fuel systems. Cam drive gears must be precisely timed with the crankshaft and various idler gears so that they're fully, completely, and correctly synchronized so the engine has the correct valve operation during its operation. Cam gear driven is also mostly interference fit to the cam and positioned by a keyway. Cam gears are heat treated and fitted to camshaft so to essentially be heated evenly to a precise temperature fitting to the camshaft. Overheating would result in premature failure. Camshafts may be rotated either with or opposite to the direction of engine rotation. That is based on the number of idler gears. So you can have a right-hand rotating crankshaft viewed from the front, and it's possible to have a left-hand rotating or a right-handed rotating camshaft either in the block or in the cylinder head. Cam gears may be spur helical cut. Thrust loads are much higher when helical gears are used, but they're much quieter in operation. Gear backlash must be measured using thickness or feeler gauges or dial indicators. Cam lift on block located cam shafts can be inspected using dial indicator mounted above the push tube or the rod. That's going to check the clearance, and you're going to see how much lift and you're getting from that actuation. Cam base circle or inner base circle is a portion of the cam periphery with the smallest radial dimension. The outer base circle is the portion of the cam periphery, so that is the larger dimension. So you subtract a small dimension from the large dimension, and that will give you your cam lift. Visual inspection of cam should identify most cam failures, but profile wear may be checked to specification using straight edge and feeler gauges. Cams should be mounted in V-blocks to test for straightness. You do that with a dial indicator, and you only allow a really small amount of run out based on the type of cam and the manufacturer, the OEM specifications. Cam train consists of serial components responsible for actuations. Most truck diesels with block-mounted cams use trains consistent with follower assemblies, push tubes, and rockers. Overhead cams used in many current diesel engines when used, the injector and valve trains are actuated indirectly using rocker arms. Most valve trains are adjusted with the lash factor to allow for expansion of the materials as the engine heats to operating temperature. Some injector pumping actuation trains are set to zero lash, even or slight load when actuating cam profile is on its inner base circle. Injector train settings may have to be precisely set because they help define injector timing. Rocker assemblies provide a means of reversing the direction of linear movement of a pushrod tube or follower. In some cases, this provides a mechanical advantage. Cylinder head valves are often used to aspirate or breathe the engine cylinders. They're actuated by cam geometry and time the air into and the end gases out of the diesel engine. Exhaust valves are often manufactured of slightly higher alloyed steels than intake valves because they sustain much higher temperatures. Both valves have the valve action and the mechanical load of the spring, but they have the thermal stress from the heat of combustion, so the exhaust valves have to do more work and be built to a different specification. So when reconditioning valves and regrinding, critical specification is the valve margin is typically around 20 or 25 thousandths. That is subject to confirmation using OEM service literature. Diesel engines do not use an interference angle to seat valves because setting contact area is compromised. A 45 cut in a valve has higher seating force but lower gas flow than a 30-degree cut. Valve seats are usually interference fit into the cylinder head and finish ground concentric to the valve guide bore. When setting valve lash, OEM specs as to engine position, the valve be adjusted should be observed because cam geometry on some engines is not clearly visible in inner base circle or outer base circle sections. Valve lash should be set using a thickness or feeler gauge. Valves in current engines are set statically, that is, the engine is not running, and cold, meaning below 100 degrees. Loose valves cause lower cylinder breathing efficiencies and what is known as top-end clatter and may damage cam profiles. If they're not serviced correctly, they can result in quick engine failure. Valve yokes bridges do not always have adjusted as part of the routine valve adjustment. It's important that the bridge be properly supported to prevent its pedestal guide from being damaged. Variable valve timing is commonly used to control exhaust valves for engine braking and also to delay intake valve closing for purposes of reducing emissions. Creating valve polar diagram is an effective way to map the valve opening and closing events in any engine you choose. You can also map how mechanically actuated injectors are phased into the cycle.